Deep in the remote, sun-scorched expanse of California, a vast and desolate lakebed holds one of the most perplexing secrets of the natural world. Here, upon the cracked, hexagonal mud tiles of Racetrack Playa, heavy boulders appear to possess an impossible agency. They leave long, deliberate trails etched into the barren earth, some stretching for hundreds of feet, as if dragging themselves across the wasteland. For decades, no human eye had ever witnessed these sailing stones in motion. The silence of Death Valley offered no immediate answers, only the haunting evidence of a seemingly impossible geological phenomenon that defied all conventional logic. Early prospectors and indigenous peoples who traversed this unforgiving terrain were the first to note the anomaly. The stones, some weighing up to 700 pounds, sat at the end of deep grooves that zigzagged, curved, and occasionally reversed direction entirely. In an environment where summer temperatures routinely shatter records and water is a fleeting illusion, the idea of massive moving rocks wandering the desert floor felt inherently supernatural. It was a landscape that naturally bred myth, yet the physical reality of the tracks demanded a rigorous scientific explanation. Examining the furrows left behind reveals a startling level of detail. The grooves plunge several inches into the hardpan, pushing up small mounds of dried mud along their edges, indicating that the earth was soft and yielding when the movement occurred. Some trails run perfectly parallel for dozens of yards before abruptly diverging, while others feature sharp 90-degree turns. This precise geometry immediately ruled out simple gravity, as the playa is remarkably flat, with the northern end sitting a mere 1.5 inches higher than the southern edge. Initial hypotheses attempted to apply conventional physics to the puzzle. Researchers proposed that hurricane-force winds, funneling through the surrounding mountains, might be capable of pushing the boulders across the slick mud during rare rainstorms. Others suggested localized magnetic anomalies, or even the persistent, albeit unscientific, notion of elaborate human hoaxes. Yet, the sheer mass of the dolomite and syenite blocks, combined with the pristine, untrammeled mud surrounding the tracks, consistently dismantled these early theories. The sheer remoteness of the site transformed basic observation into a grueling logistical nightmare. Reaching the playa requires navigating miles of treacherous, unpaved roads, and the extreme climate makes prolonged stays incredibly dangerous. Furthermore, the National Park Service strictly prohibits the installation of permanent, intrusive monitoring equipment to preserve the pristine nature of the wilderness. Scientists were forced to rely on sporadic visits, measuring the tracks with tape and compass, always arriving months or years after the stones had already completed their silent journeys. The wind-only hypothesis began to unravel under mathematical scrutiny. Physicists calculated the sheer force required to overcome the friction of a stationary, 300-pound boulder sinking into wet clay. The numbers dictated that winds exceeding 200 miles per hour would be necessary to initiate movement, a meteorological event never recorded in the valley. Furthermore, this theory could not explain why adjacent rocks of vastly different sizes and shapes would travel at the same speed, or why some would remain perfectly stationary while their neighbors embarked on lengthy treks. Geologists began to look closer at the composition of the mud itself. The sediment of the playa is exceptionally fine, rich in clay minerals that become incredibly slick when saturated with water. When rare winter storms blanket the region, a shallow, ephemeral lake forms across the basin. Researchers hypothesized that this temporary layer of water, perhaps combined with freezing temperatures, might act as a crucial lubricant, drastically reducing the coefficient of friction holding the rocks in place. Yet, even with a lubricated surface, the erratic choreography of the trails defied easy categorization. The parallel tracks suggested that multiple stones were somehow locked together during their transit, moving as a single cohesive unit. This observation birthed the ice raft theory in the mid-20th century, proposing that solid sheets of ice embedded the rocks, allowing the wind to push the entire frozen mass. However, subsequent field tests found that thick ice would simply lock the boulders to the ground, immobilizing them completely. In the 1970s, researchers Robert Sharp and Dwight Carey attempted to isolate the variables by building a corral of rebar around a specific group of stones. They theorized that if a thick ice sheet was moving the rocks, the rebar would shatter the ice and prevent the stones inside from moving. When they returned years later, the stones inside the corral had moved, while the rebar remained perfectly intact. The thick ice theory was dead, leaving the scientific community back at square one. The mystery languished for decades, a frustrating footnote in geological journals. The sporadic nature of the movement, occurring perhaps once every decade, meant that generations of scientists could dedicate their careers to the Playa and never witness a single event. The challenge was no longer just understanding the physics, but simply being in the right place, at the right time, with the right equipment to capture the elusive phenomenon. The turning point in investigating this enduring enigma arrived with the advent of miniaturized weather-resistant technology. A dedicated team of researchers launched a new initiative, determined to catch the phenomenon in the act. They could not use the native rocks due to park regulations, so they brought in their own carefully weighed stones, embedding them with custom-built, motion-activated GPS tracking units. Alongside these high-tech boulders, they installed a high-resolution time-lapse camera system and a precision weather station, preparing for a vigil that could last years. The goal was to continuously monitor the microclimate of the Playa, recording temperature, wind speed, and moisture levels with unprecedented accuracy. By correlating this environmental data with any movement detected by the GPS tracking modules, they hoped to finally isolate the exact conditions required for motion. The breakthrough required an extraordinary alignment of meteorological conditions, an event so rare it borders on the miraculous. In the winter of 2013, the researchers arrived at the Playa to find it covered by a shallow pond, no more than 3 inches deep. As night fell, temperatures plummeted, freezing the surface into a sheet of clear, window-pane ice, barely a quarter of an inch thick. This delicate frozen layer was the missing variable, a fragile mechanism that had eluded human eyes for a century. The following morning, the sun crested the mountains, gently warming the basin. The ice began to crack, fracturing into massive floating panels that spanned tens of meters. Then a light, sustained breeze swept across the valley, blowing at a mere 10 miles per hour. This gentle wind, utterly insufficient to move a boulder on its own, caught the vast surface area of the floating ice panels like a sail. The immense collective momentum of the drifting ice sheets pushed against the stones protruding from the shallow water. With the slick mud acting as a perfect frictionless bearing, the heavy rocks yielded. The GPS tracking data lit up, recording the impossible. The stones were moving. They crept forward at a glacial pace, barely inches per second, their motion virtually imperceptible to a casual observer. Yet, over the course of several minutes, they carved fresh, undeniable tracks into the submerged mud beneath them, broadcasting their journey to the waiting scientists. The surprising scientific explanation had finally been captured, revealing a complex interplay of seemingly contradictory forces. The rocks were not moved by extreme, violent storms, but by a delicate synergy of shallow water, perfectly thin ice, gentle morning sun, and a light breeze. It was a Goldilocks scenario, where every element had to be exactly right, or the stones would remain frozen in place for another decade. When the ice finally melted and the water evaporated, the Playa revealed the aftermath of this delicate, violent ballet. The sharp turns and parallel lines were no longer a mystery. They were the precise record of shifting wind directions and the rigid geometry of the fractured ice panels that had driven them. The sailing stones of Death Valley stand as a profound testament to the power of patient, empirical observation, transforming a bewildering spectacle into a profound lesson in geology and physics.